Okay, and now last but not least, Ms. Maitha from UAE.
Thank you. So, hi everyone. Hi everyone, thank you for giving me this opportunity to talk about my research, which is about in-silico identification of deleterious non-synonymous SNPs of TBX1 gene, functional and structural impact toward 22q deletion syndrome. So, to start, Dijkgraaf syndrome or 22q deletion syndrome is an autosomal dominant gene deletion syndrome caused by a 3 MB deletion of a chromosome 22, and there is multiple genes have been associated with this syndrome, but TBX1 gene has the regarded significant contributor for the Dijkgraaf syndrome, and it affects 1 in each 4,000 to 6,000 live births. And the signs and symptoms, like the patients will be suffering from heart murmur and bluish skin, facial features such as underdeveloped chin, low-set ears, and cleft palate and delayed speech development. These clinical characteristics vary significantly in terms of penetrance and expressivity, those leading toward delay in diagnosis, especially for like in patients that they not exhibit the clinical clear symptoms. And as we all know, that early diagnosis is crucial as it's linked to a better clinical outcome and early protocoled care and proper genetic counseling for both the patient and the caretakers. So this study postulates that identifying causative genetic variants in the TBX1 gene could pave the way for the elucidation of 22q deletion syndrome diagnostic markers. So our objective in this study is to predict the high-risk pathogenic non-synonymous SNPs of in the TBX gene, which is linked to 20q deletion syndrome using bioinformatics method. So our method was detect the deleterious nsSNPs, then protein structure stability analysis, observation of the protein-protein interaction, and visualize the molecular interaction network and biological pathway. And the last step was to predict the structural alteration using the Swiss model. So, because we don't have time, I will not talk about the bioinformatics tools that we use, but we use multiple tools to give the high prediction of the deleterious SNPs that can affect Dijkgraaf syndrome. So our results shows that we have 11 high SNPs or mutation that can cause this syndrome, and the protein-protein interaction network has shown that TBX1 gene have 10 partners that can affect TBX1 protein. And also the network of molecular interactions and biological processes for the TBX1 gene shows that, okay, here it's clear, shows that TBX1 gene have like a direct link between TBX1 gene and the FOX family gene, and FOX family gene also affect the development and the development of the tissues. And here's the 3D protein structure of the mutant protein. And also here some studies that shows that some patients, they have like a unique mutations, a unique like gene mutations in the TBX1 proteins that cause some hearing loss and also cause the 22q deletion syndrome. And at the end, we were able to predict the high pathogenic non-synonymous SNPs and TPX1 gene that can cause deletion, the 20q deletion syndrome using bioinformatics method. Thank you for listening. Thank you.
Dr. Haytham, thank you very much for
Welcome, thank you.
coming, and I will give you your certificate. Where is the photographer? The photographer where? Oh, yes, she's here. Thank you, Dr. Haytham.